Earlier, airplanes had their windows square. All it was still 4-engine de Havilland Comet G-ALYY took off from Rome to South Africa. Hi, I am Hilal Alam from ALZEBRA. Today we will see how an aviation crash changed the whole history of the aircraft design. Those days, the passenger aircrafts were low-flying and uncomfortable to ride. With unpressured cabins and propellers powered by noisy piston engines, they had to fly through weather rather than above the clouds. Many of them were converted from wartime bombers or freight transport aircrafts. Then came the Comet that looked like an aircraft from the future. Entered in 1952 with a mirrored aluminum fuselage and swept-back wings, it was the first commercial airliner to be powered by jet engines. Along each side were large rectangular picture windows to afford passengers unprecedented views of the Earth from an altitude about 12 kilometers. It was introduced as a flagship aircraft hailed as a triumph of British engineering. Absolutely with no competing jets yet in service, the Comet was the envy of the world. On 10th January 1954, Comet G-ALYY, a London-bound British Airways from Singapore via India, was lost near Elba, killing 35 people including the crew. Barely after 3 months, on 8 April 1954, shortly after passing Naples over the island of Stromboli, Italy, the Comet G-ALYY disintegrated. 7 crew and 14 passengers were killed. All comets around the world were grounded. There were several problems faced by the Comet. The hydraulic flying controls, the electrics and navigation system tended to overheat, and many. However, there was one particular flaw was identified. It was the geometry of the window. In 1956, Well used fracture mechanics to show fuselage failures from fatigue cracks initiated at windows caused by the insufficient reinforcements. Let us see how. The outside pressure at the altitude of 12 km is just 0.02 megapascal. The inside pressure was maintained at 1 atmosphere. The frequent cabin pressurizing and depressurizing weakened the material, also known as fatigue. The windows were in square shape with very small radius. There were rivets around the windows. In sharp corners, the stress concentration would be very high. Why? Abrupt change in the stress line results in high stress concentration in sharp corners. It's something like the vehicles get congested in sharp abrupt turns. In smooth corners, the stress concentration would be less as the stress line spots smoothly. It's akin to vehicles taking smooth turns in curves. Similarly, the stress concentration was relatively huge near the corners due to the sharp corners and the presence of rivets. As the inner pressure was sufficiently large that the material which was already in fatigue gave way for the crack to spread disastrously. Thus, the stress concentration at the corners tore the fuselage of the airplane apart. By the end of 1958, stronger, more powerful, and with much safer oval-shaped windows were introduced in the following models. The subsequent safety record of the Comet was excellent, but its reputation was forever tarnished. The longer-term legacy is that all airplanes have oval curved windows without rivets, reducing the possibility of dangerous cracks ever developing. This is the main reason why the modern airplanes have no rectangular or square windows. Why can't strong, lightweight, advanced materials solve the problem? Even if we had such materials, we might have a large panoramic windows. Yet, the aerospace engineers won't like to prefer sharp corner geometries for one particular reason: the inability of numerical analysis to handle sharp corners. Sharp reentrant corners will cause a singularity in derivatives of the dependent variables for all elliptic partial differential equations. I'll explain in simple terms. Let's take a 1 meter by 0.5 meter rectangular plate featuring a square cutout with a side of 0.1 meter that is subjected to pure tension. The two different meshes around the hole, the default plots of the equivalent stress look completely different. Since the peak stress is high in the model with a finer mesh, most details in the stress field are lost. In order to avoid such problems and singularities, the aerospace engineers avoid sharp corners in the functionally critical components of the airplanes. Hence, there is no rectangular or square windows or functionally critical components in airplanes. I can safely say we would never probably find such critical components forever in airplanes. With this I sign off. Thank you very much and see you in the next video. Bye bye.